Hello all. Today we are going to look at key paradigms in data world, data lake, data warehouse, and lakehouse. It's going to be a simple explainer. So let's start it with diagram. So I'm going to follow the structure of what happened in history as it is. So data warehouses existed for a long time. So what you see is typical source systems. It could be like a database system, FTP, an application, whatever be the source. They are actually having lots of data, which is then put into a layer which you can use for building reports, analyzing patterns, whatever it is. And for that reason, data warehouse came into existence. And the flow is typically called the ETL, right? Extract, transform, and load. So we extract data from the source system. It's then put into a layer, which I have indicated here as raw layer. Sometimes it might not be a separate layer. It could exist within the data warehouse itself. But here I have represented it as a separate layer. So the data is extracted. The key thing to notice, the data is transformed and then loaded into a data warehouse. Data warehouse, there is a schema which is already in place. If we take an example, if our order processing system is processing orders and we are going to analyze the volume of orders, what we are going to do is we are going to get all the order information, and before loading into a data warehouse, we kind of have to define the schema, saying like order ID, order price, this is how the structure should look like, and then we load it into a data warehouse. And data warehouse, you can think more like an something like a DBMS or DBMS, but not exactly an RDBMS because it follows a different modeling technique called dimensional modeling, which we'll see in subsequent videos. So what a data warehouse, just at a one level, if I have to say, it's schema and write, because you'll have to decide what you are going to put in, and then which will be eventually be used for your reports or answering analytical queries, all those things. So this is supposed to handle huge volumes of data. Previously it was on-prem, right now it's with cloud data warehouses are a thing. It's very easy to configure. This used to work, but there are some challenges in it. Obviously, yes, that's the reason there are other paradigms, right? We are able to kind of query the predefined patterns because we have applied the schema, and many times we'll have to kind of model the schema upfront. But the ecosystem was always changing. What if I had to take in unstructured data? Maybe like something like video files or even some log scrapping, where I wouldn't be able to kind of apply the schema upfront. Maybe I want to look at a different schema while processing. All those things came into picture, and what we found is like data warehouse is not going to scale for these requirements. This led to a different paradigm, which is data lake. Now, what's data lake? Again, the problem which we try to solve is unstructured data. So with cloud and kind of object storage, I would rather say the unstructured storage, which we really needed. I mean, it would have been even possible in on-prem cases, but yeah, with commodity hardware and all those things. But I'm just taking an example of cloud. With cloud object storages like S3 or Google's cloud storage, or with Azure storage, all of those things are able to kind of provide cheap storage and also like unlimited storage. This paradigm really emerged. So what we have is kind of an unstructured storage, where typically what happens is we extract data as it is, which is stored in the raw layer, which you can kind of think in data warehouse or we add a raw layer where we kind of extract the data. But then the paradigm changes here. We are not actually changing or transforming schema or putting a new schema onto it. Whatever data we are loading them as it is to the next layer. Again, all three layers are in object storage. These are logical layers, so that we can understand. So it's single object storage. You can even say like if you are familiar to S3 or something, you can think like it's buckets. So different buckets. So the data from raw layer is loaded into an optimized or process layer. What is optimized or process? It is just I mean, not to go into detail in this video, it is maybe you can think like the data is clean. Maybe there are some bad records which you want to remove, some small validations. Still, we are not changing the schema. You can change the file system format, which again we will cover in subsequent videos. Basically, there are different file system formats optimized for different types of queries, can give you good performance and all those things. So it is kind of just changing the underlying way it's done, but the schema essentially does not change. We have not even actually applied a schema. We are just using the same schema as we got from the source, and then we are putting in an optimized layer. And this actually opened up the data to many consumers. So typically the data scientist or people who want to run ad hoc queries even before the report is being published, right, actually look at this particular layer. So they try to kind of query, get information from this, and then actually even think whether of building a report or a dashboard or even trying to take a business decision. So this enabled to get data as it is, and this is what I would term as like schema on read. So typically why I even say that is, right, we are getting the data as it is. So we are just putting the data, loading it, and then while we are actually querying, we are applying the schema. So we are actually saying how to read the data. So that is like a schema on read. Then if there are reports needs to be conducted, I mean like maybe published or a dashboard needs to be created, they would optionally include a reporting layer. So reporting requirements are obviously going to be there. So some reporting requirements are going to be there. So from the optimized layer, there will be another layer which will have, which is again another storage layer in cloud. You have a reporting layer, and this is where the transform is applied. Now you are saying like, okay, I need a report to be published, so I need the data to be in a particular schema. So you are transforming it to a particular thing. So here it's no longer ETL, which is extract, transform, and load. Whereas here it's like extract, load, and then transform. So we are getting the data as it is. Now, okay. So we saw data warehouse and data lake. Is this sufficient? Can we kind of combine both the approaches? Yes, there has been instances. Typically, what happens is like data comes into data lake. From there, it's loaded into a data warehouse, and from data warehouse, people can use it for all the analytical plane operations. While the data lake, which is like till the optimized or process layer here, all these ad hoc queries can be run. This is also a very established pattern in industry today. But something new is also emerging, which is called Lakehouse. So why Lakehouse actually came into picture? The thing is, I know we are already getting a lot of data in real lake, so we are having it. Then we also needed to load it into a data warehouse, because for all analytical queries, data warehouse is going to be very fast. It's going to have a good schema. So it's kind of like the best thing to have. But that means that we are having two different systems for maintaining, and that kind of led to the paradigm of Lakehouse. Can we actually have a single system where we can kind of do all of those things? People might say, yeah, in data lake itself, you can have a reporting layer, but that's again not very scalable, right? Every time you have to create a schema and all those things, you are actually trying to build a specific schema from other than the application schema, and it's going to involve a lot of doing ETLs and all those things. There are some tools which even solve this challenge. I'm not going to go in detail into that. It's going to take time. But considering if this is not scalable, instead of maintaining a data warehouse, can I get the same level of data warehouse performance, but within a data lake? So this Lakehouse is being touted as the answer to that. So when you look at Lakehouse, it would look like similar to a data lake. So it's like, yeah, you have three layers, which is what we saw earlier. And you have like raw curated and reporting, but it's just named as raw curated reporting layer. I've maintained here as limited reports, but it's actually not limited reports. People can do more reports. But what's changed here? So if you look at from the diagram perspective, it looks very same. But what is the challenge in data lake? The thing is, it's schema on read. So people can read kind of like, I mean, we are not validating the data. We are not saying like the data is going to be of the same schema. We are just saying while reading, we'll have to apply schema. So the consumer has to put a lot of effort while reading. But instead of this, can we do something else? Can we have a schema which is there in curated layer itself? So still it's object storage. So the actual data is in file systems. So we are not using any specialized warehouse technology or something. but it supports having a schema. So you kind of can't put bad records, or even I would say like records without a particular schema. You have to get good performance, because in warehouse that's the another thing. And you need some level of acid properties. I mean, atomicity, consistency, basically like if at all I want to make an update, let's say we want to say this order has been cancelled. In a lake, you never kind of make a change. You always insert a record saying like, okay, this order has been published, this order has been cancelled. In warehouse, you can go ahead and immediately update the status. Now here, if you have to do that, typically in data lake, if you have to do that, you have to actually search for that record in among multiple files and then actually make an update. If you are going to do that, it's going to be very costly. But can this all be simplified? That is Lakehouse. So the way to do that is there are options, there are optimized file systems. I would kind of call out 3 file systems here. I'm not going to go into detail. That's going to take way longer than what I imagine as part of this video. So I'll just name them. One is Apache Woody, which is I would say very popular, at least in AWS ecosystem. Then there is Iceberg, and then there is Delta Lake, which is very famous in Spark ecosystem. So these 3 are enabling the ACID feature, the kind of like a good schema feature where we are sure that this is what we are going to get while reading. So this kind of enables what we call as Lakehouse paradigm. So again, this trend is, I would say, emerging, and people are kind of saying like, okay, this is going to be the next thing. This is going to be data warehouse killer. I'm not too kind of, I would say, like, rather I'm waiting for the trend to emerge, but this is what it is. So this kind of enables people to say like, without a warehouse, I can have my data lake and use this to kind of do both reporting and ad hoc queries and even building ML models. So yeah, I will leave this video with this content. I'm going to subsequently delve deep into all of these sections. Please give your feedback and comments. I would rather say, yeah, I'm waiting more to hear from you. Like, what do you want to learn more, or what do you want to hear more from me? So, yeah, that's pretty much this. Thanks again. See you.